Hi children, welcome back to our channel and Vinay Kumar Basics of Physics. Children, in this video we are going to discuss about the photoelectric effect. What is the photoelectric effect and how the electron can be eliminated or removed from the metal surface? How many processes are there? And what is mean by work function? You have to learn all these things from this video. Clear children? This is the first video of the chapter Dual Nature of Radiation and Matter. This topic is related to the intermediate children. It is useful for IPE, at the same time for other competitive exams. You have to watch the video up to last very carefully children. Okay children, here first thing is we have to learn about the photoelectric effect. It is the important question for 4 marks. Simultaneously it is important for 8 marks also. And children, here we know that atom consists of electrons. Those electrons are, some of them close to the nucleus and some of the electrons are far away from the nucleus. The electrons which are far away from the nucleus, generally they are called as the valence electrons or free electrons. These electrons can be loosely bonded to the nucleus. That's why to remove the electrons from the any metal surface, we have to apply some energy. Clear? In a metal there are a lot of atoms are there. In those atoms so many number of valence or free electrons are available. Here my question is, why the electrons are not coming out from the nucleus when they are very free and they are loosely bonded to the nucleus? Because the positively particles or the positively ions which are inside the atom, they always attracts the negatively charged particles like electrons. That's why even though electrons are wants to escape from the metal surface, but it is not possible to for them. Even though by chance if any one of the electrons came out from the atom, it is immediately attacked by those positively charged particles. That's why there is no possibility for the electrons to come out from the atom. So even though they are freely electrons, we have to apply certain amount of energy, because the energy what we are applying, that should be more than the attractive energy between the positively charged particles and electrons. When the applied energy is more than the attractive energy, then only the electrons will come out from the metal surface. Children, why we are talking about the removing of electrons? Because the electrons are responsible for the current. Here in this chapter there is one special case for children. Generally what we know, when any conductor is given to the battery, the current will be passed through the conductor. That's we know that. But in this case there is one lot of very interesting thing is, when light is fall on the metal surface, then the electrons are released. That is we are going to discuss. The energy that should be what it is incident on the metal surface, that is obviously light energy. When light energy is falling on the metal surface due to that particular kind of energy of photon energy, the electrons are removed or came out from the metal surface. That is the phenomena actually what we call photoelectric current. Clear children? That is we are going to discuss, because in this one chapter the electric current is because of only light. Clear? Okay children, so I am coming to the topic here now. photoelectric current. Photo means what? Light energy. Electric means what? Electrons. And current, what is current? Flow of electrons. In title only we have the story, photoelectric current. When certain amount of light energy is incident on the metal surface, then the electrons are liberated and they can be moved. Then that process what we call photoelectric current or photoelectric process, and those electrons are called photoelectrons. So this is simply about the photoelectric current. What is it, children? When certain amount of light energy is falling on any metal surface, then the electrons are liberated from the metal surface and the electrons are moving. Then what you have to say, that phenomena is photoelectric process and those electrons are called photoelectrons. Okay, children, here before going to the experimental procedure, there are three possibilities for the liberation of electron from the metal surface. There are three ways. The first thing is here, thermoionic process and field emission process and photo emission process. To liberate the electron from the metal surface, there are three processes. First one is thermoionic process. Thermoionic process means when we applied certain amount of heat energy, that means when we are heating the metal surface, then the electrons are liberated. Then that phenomenon what we call thermoionic process. And children, if we can apply certain amount of voltage between the ends of a metal, then also electrons are liberated. That phenomena what we call field emission. When we created certain electric field between the ends of a metal, then the electrons also liberated. That phenomena what we call field emission. Clear, children? And third one is just now what we discussed, that is the photo emission. When certain amount of light energy is falling on the metal surface, electrons are liberated. Then the type of phenomena what we call photo emission. Thermoionic process means we are applying the heat energy, and field emission means we are applying the electrical energy, and photo emission we are using the light energy. So by using these three type of energies, there is some possibility for the liberation of or removal of electron from the metal surface. Got, children? And children, here there is one particular definition for you that's very important for 2 marks. That is, what is mean by work function? What is mean by work function? Simply the minimum amount of energy. The minimum amount of energy that should be required to remove at least one electron from the metal surface, then that particular energy is called work function. Clear? What is work function? The minimum energy required to liberate the electron from a metal surface. That should be what we call work function, and that work function is, that should be shown like this, W naught. What is that? Work function is what? W naught. And children, the amount of energy is nothing but to remove the electron from a metal surface is, that is what? 1 electron volt. That should be equals to the 1.6 into 10 power of minus 19 joules. 1 electron volt is equals to 1.6 into 10 power of minus 19 joules. Clear, children? So that is the amount of work function. Okay, children. Now here we are going to discuss about the experimental procedure. Experimental procedure to explain the photoelectric effect. So the scientist was name was Hedge. Hedge can explains the photoelectric effect. So children, watch carefully. There is one diagram on the board. You have to observe very carefully. So Hedge, the scientist name is what? Hedge experiment. So in that he was taken, this is the evacuated glass tube, simply generally what we call discharge tube, we will call like that, evacuated glass tube. In that two electrodes are there. It is, I am saying C and it is A. So here one electrode is C and one is A. Generally what we take, that is here collector, and C is called emitter. Clear? There is one evacuated glass chamber, it is there. In that we have to insert two electrodes. One is called here C and it is A. C is nothing but what I am going to say, emitter, and A is nothing but collector. Emitter means what? Which can emit the charged particles, that is the emitter. And collector means what? The electrode which can collect the charged particles which are coming from the emitter. That is what we call obviously collector. And now children, here there is one arrangement, it is there. It is like a window that is made up of material is quartz window. What is that? Quartz window. And this is the source of light. So it is almost all ultraviolet radiation. Ultraviolet radiation. Simply I am going to write here UV radiation. Clear? And it is a source, like nothing but sunlight. And again this C and E should be connected like this. Here you are finding some 4 dots. It is nothing but it is commutator. What is commutator? It is the device that should be changes the direction of current in a circuit. To change the direction of current, we can use one device that should be what we call commutator. And next children, to find out the potential difference, here VD is there. V is what? Voltmeter, and this is what? Ammeter. And again it is the rheostat, and like this here the connection should be like this. Simply here this is C and this is A. The entire thing should be here like this. This is the experimental setup for the photoelectric current. Clear children? So here the next thing is here you have to learn this one very clearly. Quartz window, emitter and collector. So here we have to guess what will be happen. There is one source, it is there, that will release what? Ultraviolet radiation, certain amount of light energy. That light energy is falling on this emitter. This emitter is nothing but photosensitive material, anything photosensitive material. Here what is meant by photosensitive material? That should be reacted to the light. When certain light is falling on the materials, they will make some scintillations, or they can make some releasing of some particles. Those are called photosensitive. They are reacted to the light. Here children, look here. S is the source of light. From that source light is coming, and that should be false on the C. Then what you have to say? It is the metal. On that metal energy is falling. Then obviously what you have to say? Some electrons are released. Those electrons are moving towards to A. Moving towards to A. So initially here children, that C is having some negative charge and A is having some positive charge. Clear? Here there is some commutator is there. what is the meaning of commutator? When we are using the commutator, the polarities of A and C will be changes automatically. To change the polarities of A and C, we are using some commutator. Children, what I am going to say here, collector is having some positive charge and this one is having some negative charge. So here, that's why what you have to say, you have to observe one thing clearly. When electrons are released from the emitter, in which direction they are going? Towards A. Why it is going towards A? What is the charge of emitted particles? Negative. We know that because it is a photoelectric emission. That's why here the electrons are having some negative charge and they are moving towards the A. It means that the charge of A is positive. Positive charge of what is A. And here, when the value of A is positive, the electrons are easily attracted towards or reaches the A. That's why it is called collector. The emitted electrons must be collected by the A. That's why it is called as collector. So obviously we know that what is the current flow of electrons from one place to the another, what we call current. In this case, the electrons which are emitted from the emitter, they are also moving from one place to the another place in the discharge tube. That's why the stream of negatively charged particles here called nothing but it is current. So that's why it is called photoelectric current. Got my point, children? When certain amount of energy is incident on the metal surface, the electrons are liberated and they are moving towards the collector. This process will be continuous up to what? When the light is continuously falling on it, electrons are liberated and they are moving towards the collector. So, and here, how much photoelectric current should be in the circuit? That should be measured by the ammeter. Clear? So here, ammeter will shows the more reading. What it is means that simply more number of electrons are liberated. When it is showing some lesser value of A, current value is less, it is showing, or it means less number of electrons are liberated. So that's why here the intensity of light is also decides the how many number of electrons. So already we have some topics on the intensity and frequency and how the intensity and frequency will affect the photoelectric current. I will explain in the coming videos. So just you have to know that simply C to A, you have to observe that electrons are liberated, they are moving towards the A, and flow of electrons what we call electric current, and the current should be shown by the A. When more electrons are moving towards the A, the reading will be shown is more. If less are going, it will shows the less reading. And the voltmeter what it is there, that should be shows the how much potential applied between these two. Okay, children, this is simply about the photoelectric effect procedure, experimental procedure. The same procedure will be explained in detail in the coming two videos. Effect of intensity on photoelectric current, effect of frequency on photoelectric current. So I hope that this topic is very clear to you. I think so. So if you can understand this one, like, share, comment the video and subscribe my channel too. And my request is please share our channel to your friends who are interested to learn the studies in this pandemic situation. Okay, bye, take care.